I'm Therese, and in this video I will show you how to create your own secret safe that will only open if you knock using the right code. Do you remember a component called piezo? It's a little speaker that we used in project 6 and 7 to create musical instruments. It can not only play sound, but also detect vibrations. If you haven't checked out these projects yet, I recommend that you do it before doing the knock lock. To lock the safe, we'll use a servo with an attachment. If you don't know how to use a servo with Arduino yet, check out project 5. We will also use a switch to turn the lock on and off, and some LEDs to indicate the status of the lock. To create the safe itself, you will also need an empty wooden or cardboard box. But first, let's create the circuits. As always, make sure that nothing is connected to the board, and I've also prepared the breadboard by connecting the ground and power rails on both sides. I will start by connecting a push button with a 10K pull-down resistor the same way as we've done in many of our previous projects. Check out project 2 if you're still unsure. The state of the button will now be read by pin 2 that is connected to the resistor and ground side of the button. Next, I'll connect the piezo, and since we're using it to detect sound instead of playing sound, I will connect it a bit differently from how we've done it before. When using a piezo as a vibration sensor, it can generate large voltage spikes, so we need a 1 mega ohm resistor to dampen it in order for the board to read the vibrations properly. Connect one terminal of the piezo to power and the other to ground through the resistor. Leave some room for the analog pin wire. We will read the analog value from analog pin 0, which in this case will be used as an input pin. Now it's time to add the LED indicators. Connect the red, green and yellow LEDs to the breadboard in the same way as we did in project 2 and connect them to digital pin 3, 4 and 5. Finally, we'll just need to add the servo in the same way as we did in project 5 with a capacitor. Make sure to note where the terminals for power, ground and signal are on the header. Now we can take a closer look at the code while uploading it to our board. We start by importing the servo library, and as usual, we create the constants to name our inputs and outputs, as well as the variables that holds the values from your switch and piezo. We will also set up the constants that define the threshold values for the knock sounds. You may have to change these values later for the piezo to detect your knocks depending on your circuit and surroundings. Finally, we define the variable that tells us if the secret box is locked or not. The data type boolean can only be true or false, and we should set it as false, which means in this case unlocked. Read more about boolean from Arduino's reference page. In the setup, we attach our servo to pin number 9 and set the rest of the components as outputs and inputs. As well, we initialize the serial communication. When we start the program, the green LED turns on, the servo's shaft turns to the position of 0 degrees, and a text "the box is unlocked" is printed to the serial monitor. In the beginning of the loop, we have an if statement to see if the box is unlocked. If yes, we read the value from our switch, and if you're pressing the switch, the box gets locked. If the box is locked, we read a value from our piezo and store it to the variable called knockval. When the number of knocks are less than 3 and the piezo detects vibration, we can check to see if the knock is valid. For that, we will use a custom function called check4knock and set knockval as its parameter. If our function returns true, we'll increase the number of knocks by 1. When the number of knocks is 3 or more, the box gets unlocked and we can open it. When we create functions, we write them outside of the loop. We also need to indicate if the function is going to return a value. In this case, when we call the function in the loop, we will get back either true or false. Also, when we call the function in our loop, we set knockval as the parameter, and the value is stored to the integer value only used in this function. Then we check if the value read from the piezo is between the values as we used as thresholds. If yes, it is a valid knock and the function returns true. If the value is less than your quiet knock or greater than your loud knock, the function returns false. Now we should try out if the project works as intended. Now the lock is off and the green LED is on. If I press the button, the locking mechanism will go on and the LED will turn to red. If I knock on the piezo with a correct knock, the yellow LED will turn on. If I knock correctly 3 times, the lock will open. I have assembled a secret box using a cardboard box, a scissor and some tape. You can also use a starter kit box for this. Next time, we're going to use aluminum foil and an LED that lights up when we